Okay, everyone, we're going to get started here. We'll probably have a few more people funneling in as we go, but today we have a panel discussion from the National Severe Storms Laboratory, which is a very important part of research in severe storms and severe convection. So we're excited to have them, especially on the eve of such a big severe weather event here in the Midwest. So we heard from Jensina this morning. We kind of hear from the people who research and develop some of our convective allowing models and such. So we're excited for this. Announcements. Our next general meeting is going to be April 11th. Liz Lightman from the Storm Prediction Center is going to talk a little bit about what she does day to day. I know we've already heard from Rich Thompson, but we get a sort of multi-forecaster perspective. And then we have a couple social events coming up. I'll send emails out regarding that. And those will also be posted on the social media as well. So we hope we can get as many people to the social events as possible. So without further ado, I'm going to toss it over to you guys at the NSSL. Get us started. Oh, sorry, you guys are muted. Can't hear you yet.
They muted themselves.
Okay.
And then when you
I had to stop sharing in order to unmute, so we're going to have to figure this out. How to
share it again?
Yeah.
Unmuted?
We'll give it a try.
share tab out, turn out, maybe,
Oh,
turn
maybe,
that off?
Sure.
Yeah, turn that off, because we don't have any audio.
or share entire screen. That might do it. Yeah.
Nice. This could be dangerous.
Okay, yeah, no, we're
Right.
good.
I think now you're still hearing us.
Yep, we can see you.
All right, great. Yeah. If that's the biggest technical hurdle that we face today, then I'm okay with that. So again, thank you for inviting our group to speak with your chapter there. My name is Patrick Burke. I'm the lead of the War on Forecast program here at NSSL, and most of the folks that we have in the room are involved in War on Forecast. So I have a few slides to talk a little bit about the lab and what we do in our division. But then we're going to go around the room and introduce, everyone will share a little bit about what they do in particular. And I know there was some interest on your end about hearing about career paths and kind of how we got to where we are. So we'll introduce ourselves in that way, and then just kind of have a nice back and forth, I hope, with a lot of discussion. So this can be pretty informal, and I think we put together some nice slides for you just to kind of get us all primed for that discussion. So you see the names on the screen there, that's who's in the room, and they'll be able to introduce themselves here in a moment. So I don't know if it's always clear, you know, with the different hierarchy of how all the offices in government work. So I just wanted to kind of make sure you understand who you're talking to. We all do work for NOAA, and the laboratory at NSSL is one of the many laboratories that are part of the Oceanic and Atmospheric Research organization, the wing of research in NOAA. And some of us are federal employees, others work through the Cooperative Institute here at the University of Oklahoma. So that's the Cooperative Institute for Severe and High Impact Weather Research and Operations, or CIRO. And you see their staff in a recent picture in the lower right there. They provide a lot of the workforce here for our research and development activities. And the lab as a whole, we're kind of split among several different divisions that do different things. We have a lot of field projects. We have a radar division that for decades has been instrumental in developing Doppler radar and applications. We have a warning research and development division, and they're doing things like threats in motion, changing the way that the Weather Service will issue their severe thunderstorm and tornado warnings in the near future. And then we have our forecast research and development division, and that's who you're speaking to today. So in the forecast group, a large percentage of our work is the War on Forecast system. So I'll be glad to talk about that and answer questions about that as we go along. So we don't work directly for the National Weather Service, but the National Weather Service is one of our key customers. And so I've got a picture up there in the upper right of one of our scientists embedded in the operations here at the Norman Local Forecast Office during a severe weather event, helping them to interpret the experimental WAFS output. And so it's just kind of a visual on what we do at the lab. I think of it as it kind of ranges from field studies, understanding how thunderstorms look and behave in the real world across that top panel. At the bottom, you see a lot of satellite and radar data. And so we have, a lot of folks and engineers and technicians and meteorologists who are making the radar data in particular as good as it can be and working on our next generation radar system. And then in the middle slot there, I have some images from the War on Forecast system and how we describe thunderstorms in a model sense and in a predictive sense. On the right-hand side, those are words. It's a word cloud that I made from publications out of this group over the past, I think, 6 years or so. And so you can see that this is what we spend our time doing in the research wing of NOAA, is thinking about things like experiments, machine learning development, guidance for different hazards, making the best use of the radar data that we can in our forecast models. That's a key component of the War on Forecast system, is that ingest of both radar and satellite data. And so it's a really exciting place to work, and we get to produce these interesting projects and interesting outcomes. So I'll leave it at that. But what drives a lot of our work are initiatives that come from at higher levels, either at OAR or even at the congressional level, with when the Congress passes anything that has to do with weather research. Money for that tends to trickle down to the laboratories. And so War on Forecast is in part contributing to things like the Tornado Warning Improvement and Extension Program, which is to, the goal there is to improve the lead time, just exactly for the events like we saw last week in Mississippi, and that I hope we don't see tomorrow. But the War on Forecast system is really the first of its kind as a storm scale ensemble that's designed to make predictions of individual storms. So the concept is that most numerical modeling traditionally has been designed towards answering kind of next hour or next day kind of questions, regional kind of questions, whereas we are keeping up with individual convective updrafts, assimilating them into the model very quickly, and then putting out a new forecast every 30 minutes. And I just wanted to show one example of what that means and what it can do. Looking up at your neck of the woods, this is the June 13th supercell from last year, where the storm initiated just upstream from Chicago and produced a number of impacts at O'Hare. You name it, it was wind, hail, very large hail, and there were tornadoes within a couple of miles of the airport. And the War on Forecast system did a fantastic job of catching that cell, which initiated pretty close to the city, but we got it assimilated, and with about an hour's worth of lead time there, it's predicting a high probability of severe impact right along the track. And so a lot of our work has been to develop efficient kinds of ways to visualize this system and the ensemble output, so that it can be produced efficiently and quickly, so it can be used for warnings and also interpreted quickly. All right, so now we'll get kind of going around the room. And then we'll get to our panel discussion. So I just wanted to kind of show here my path to where I am now. I'm actually from Oklahoma originally. I grew up in the Oklahoma City area. So I went here to OU for my degrees back kind of around the late 90s to early 2000s. So 99, this famous tornado here is from the May 3rd, 99 outbreak. I was actually chasing with the NSSL crew at the time because I was a student here, and that was my view of the tornado in real time. So it's kind of used on a lot of our brochures and things these days. So every time I see that,
Is that your photo or just your view?
It's actually Daphne Ledoux's photo, but I had the same view.
It was your photo.
So I stayed, that was I actually graduated my bachelor's degree that week. That it was 5 days later. Yeah, and then stayed on here at OU and did research into BOECA and derecho systems for my master's. But I wanted to go into the weather service. So sometimes you have to go to kind of a lonely outpost to get your foot in the door. And so I went on the map there, you can see I went up to Western North Dakota for a time, where the picture here is me operating a 1974 radar that was at the local, it's not even a WFO, it's a WSO.
Just like an observing station.
Yeah, a lonely outpost. We had a 3-county warning area, and that radar helped fill a gap in between the 88D network. And there was just a powerful senator who was able to keep that office open until he retired.
That's amazing.
Basically. So that was my foot in the door. But I ended up, I worked at the Goodland, Kansas office and then Norman, Oklahoma for several years. Then expanded my horizons to the Weather Prediction Center. So I was at one of the national centers for a long time. And there I kind of, you see it from the map in the orange that I got to really expand what I was looking at by being at WPC. We had medium range forecasts that went from Japan to Greenland. And then we did a lot of things with the Hurricane Center. WPC is actually the backup to NHC if they were to go down. So we worked pretty closely with them, and I learned a lot about tropical weather. But the place that I really focused on while I was there was the heavy rainfall desks and flash flooding. And there's an article that I've led, which I believe is going to be on the cover of AMS within the next couple of months. So I put the cover over there. But eventually made my way back here to Oklahoma, which is my home. And now with the War on Forecast program, this is just a fantastic job. These folks have put together a wonderful system that everybody's excited about, and I just get to go do outreach and talk about it and praise what you've done. So it's really fantastic. All right, who's next?
That's Monty.
Monty.
Oh. Do you guys have any questions for Patrick at this point?
Well, I think maybe let's just get through everybody, because then we'll have a panel discussion. So
Okay.
if you don't mind holding your questions, or we can let Kelvin decide that.
Well, I feel bad because this gets out of order because I have a good introduction
That's
slide.
nice.
Oh, okay.
We can go back.
That's fine.
There you go.
Okay.
Yeah.
So I'll give just a brief introduction before I get into like all of my research stuff. I'm from the South Bend, Indiana area. You probably know it better as Notre Dame, little tiny town in the Midwest. I actually started school as a philosophy major. I was really pumped about it because I hated math, but at some point I had like an epiphany and realized I actually really love math. So I was like, I don't want to do philosophy anymore. So I switched universities and went and did geography, because that's where my now wife was going to school. So I was like, hey, I'll go do meteorology. Why not? And so Dr. Coy Poppin, if you can see him back in the blue shirt, was actually my advisor in 2014. We were doing like supercell and resolution work. And then ever since then, I've been at OU. I did my master's, PhD, postdoc, and now as a research scientist with CIRO here down in Oklahoma. As for what I do, I'm an AI person. I do machine learning. So what we're trying to develop is generating probabilistic guidance using warning forecast for the individual severe weather hazards. So trying to alert our forecasters where severe wind might be possible, large hail, and or tornadoes. So we use past WAFS data over like a 5-year period, and use that to try and predict the likelihood of observing one of these hazards in the future.
Okay, and like Monty said, I'm Corey Potvin. I grew up in a small town in Maine. Some know it as the Dirty Lou. It's got a bad reputation and it's well earned. Kind of a bit of a drug infested downtown and stuff like that. But anyway, I went to school at Linden State College. I'm actually not, the name has changed a couple of times. I'm not sure what it's known as now, but that was a very small school in the Northeast Kingdom of Linden State, but that they had a good meteorology program. So I got my bachelor's degrees there. And while there, in summer 2003, if you look in the upper right, I did an REU, research experiences for undergraduates here at the, well, no, yeah, it wasn't here at the Weather Center because it didn't exist, but back then it
I
was.
was looking at that, like, I don't think that's you.
No, it's not me. That's a more recent picture, some other year, but it was the CAPS REU back then. So yeah, we didn't have this awesome building back then. It was built in 2006, I believe. And then, yeah, so I did that here in Norman, and that inspired me to apply to OU for graduate school, because I knew I wanted to work on severe weather. So I got my master's and PhD here, graduated in 2010, focused on radar-based wind retrieval algorithms, including dual Doppler retrieval, if you've heard of that. Then did a postdoc, and then was hired as a research scientist here at CIRO, although it was SIMS back then, working on storm scale analysis, and then transitioning onto the Warn on Forecast team. And then was hired as a federal research meteorologist here at NSSL in 2019, and yeah, I've worked on Warn on Forecast ever since. And if you wanted more details, I've got my professional webpage linked there. If Patrick's, if you plan to share the slides with them. And then, so here's just kind of a sampling of recent work I've done, and I actually do have the papers linked here if you're feeling particularly ambitious. In the upper left, that shows a storm identification classification technique that I developed with others here at the lab. So trying to, identify storms and then, determine whether, this is a supercell, is this a QLCS, is this a rotating cell embedded within a QLCS, and so forth. So that is obvious operational applications and research, lots of research applications as well. And then if you look in the upper right, that's some work I did. So the Warn on Forecast system uses different physics schemes among the different members comprising the system. So I looked at the impacts of some of those different physics schemes on the actual forecasts generated by those ensemble members. So here you can see one scheme produces slightly higher or slightly lower CAPE than the other schemes, and as a result, slightly lower updraft scheme speeds and storms. And then in the lower left, that's showing the impact of going to higher resolution in the Warn on Forecast system forecasts, so which are currently at 3 kilometers. So this is some early work, and there's been a lot more work done since looking at the impact of going to higher resolution, like 1 and 1.5 kilometers. And then this work showed that, not surprisingly, we can get better predictions of strong low-level rotation in storms if we do go to higher resolution. And then more recent work, which I actually I'm about to submit once I get approval on NSSL's end, This is using machine learning to forecast skill. So actually trying to anticipate how good war and forecast system forecasts are going to be, kind of like different convective regions. So yeah, it's kind of a, oh, what's the word I'm looking for?
Meta. Very
Yeah,
meta.
it's kind of meta. Yeah. Is that term still in vogue?
I don't think the word in vogue is in vogue.
Well, that's definitely, I know that. I mean, is that term still on fleek?
Oh, God.
No, we're vibing with that
Or-
term.
That was a very short.
And then we're gonna develop a new algorithm that verifies how well his machine learning.
Yeah. See how far up we can go. So where no one knows what the heck I'm talking about.
It's like that movie Inception, right?
It's like,
Yes.
yes, we're gonna go all Inception on this.
Good afternoon, everyone. I'm Kent Knopfmeyer, and this is my road to Norman. I grew up in Evansville, Indiana. From a young age, I was always interested in weather and severe weather. We didn't get as many supercells, but we got a lot of QLCS storms and tornadoes. So I was always interested in weather. And I was also grew up in a family of Purdue graduates, so I always was wanting to go to Purdue for college. And luckily, I found out in 8th grade that they had an atmospheric science program from our pharmacist who roomed with an atmospheric science student. So
Pharmacist?
yeah, so and Purdue has a big pharmacy school too. So there's a lot of pharmacists that are Purdue graduates. So once I knew that Purdue had meteorology, I mean, at that point, I was maybe prepared to be an engineer or something else, or computer science, or something along those lines. But once I heard they had meteorology, atmospheric science, I said, well, that pretty much sells me. So I went to Purdue, got my bachelor's in 2005, got my master's in 2007, studying with Dr. Jeff Trapp. And then I was kind of a little bit unsure if I wanted to go get a PhD. And my primary reason, or the reason I wanted to go get a PhD, was primarily to teach. And so I went to Penn State, started working with Paul Markowski. But then kind of, thinking more about, did I really want to be faculty and just teach? And also at that time, looking at kind of what was out there in terms of teaching faculty positions. I know that's increased a lot, so there were more of those positions, but in 2009, there really weren't a lot. So just kind of started questioning, is that what I really wanted to do? Decided that it wasn't what I wanted to do. So then in 2009, which granted wasn't a great time to be looking for a job, but luckily, position opened up at Sims, working with Dr. Dave Stensrud, who's the soon to be retiring department head at Penn State. Working with him on his various projects, WRF related. I worked on things like even something diverse as tropical easterly waves, just kind of various projects that Dave was interested in. And then in 2013, my job description kind of changed, and I started working more closely with the HTIP, the Hazardous Weather Test Bed, and also the War and Forecast group. So what would you say I do here? I wear several hats. Some have been added recently. The image on the left displays data from the various convection allowing models that we run here at NSSL every day. I had been managing the execution of the model runs themselves, but recently took on managing the website to generate all the images that you see there. And you can see on our website, and I encourage you to go there. They run every day. We have several runs. We've been starting a new runs based on the model for prediction across scales, or MPAS. And so all those are on there. You can see, we also have our legacy Nussel WRF run that's on there. So you can look at everything and see how those runs compare day to day. The upper right is the War on Forecast, my War on Forecast activities. I was very much on the ground floor when we started, at the point of, can we do this? How's this going to work? And through a lot of good things and a lot of, I'll be honest, a lot of suffering, which still continues to this week even, to get the War on Forecast system up and running and getting it to display to forecasters. And I'm very happy that the forecasters have been so excited to look at it and been able to use it in their forecasting activities. That was always the goal. As part of my master's work, I did numerical modeling, and improving forecasts was always a very strong interest of mine. So the position I ended up putting me in the spot of my other interests. So that was very rewarding. And so in 2013, as I mentioned, I started working with the hazardous weather test bed spring forecasting experiment, where I've been a facilitator and also managed the data flow for that since 2013. So ramping up, it's almost April 1st, everything's starting to ramp up. So we're excited for another year of the spring forecasting experiment.
Let's take the keyboard from you. Can I have little pop-ups?
Cool.
My name is Larissa Reams and I work here at CIRO. I was born in Plano, Texas, so a lot bigger than most of you guys' hometowns. It's bigger than Norman, that's for sure. Sorry, that's Oklahoma City. I was born in Oklahoma City. What am I saying? I was born in Oklahoma City, like Patrick. That's what Oklahoma City looks like now. Did not look like that when I was born. Oklahoma City has definitely come a long way, 35 years. When I was 3, we moved to Plano, Texas, just down the road, about 3 hours from here. That's actually pull in Plano with a dot where Plano is. About the time that we moved to Plano was when my mom said I started staring at the window at storms, and she thought I was scared. So she played it off every time I'd ask questions about it. And then she realized I was fascinated from the time I could talk. So like Kent, always interested in weather from a really young age. And when I finally realized that that's what I wanted to do with my life, coming back to Oklahoma, where I still had a lot of family, certainly made plenty of sense. So I came to OU for all 3 degrees, my bachelor's, my master's degree in, I looked at forecast, how soundings differ for significant tornadoes at night versus in the day, and what model forecast soundings, what predicts tornadoes better at night versus during the day from modeled soundings. And my PhD was on the interaction between urban environments and supercells with high resolution WRF simulations. So I graduated in 2017, and then I did a postdoc with the National Research Council here at NSSL with Dr. Adam Clark. And that was also on how forecasting skill changes from nocturnal severe weather to nighttime severe weather. And I did that, didn't finish my 2 years before CIRO and NSSL opened up a job. And I've been here ever since. What do I do here? This is an animation of the lovely webpage that Kent now works with us. One of my main roles here is working on these models, getting them running, making them better. When people notice problems, I help implement solutions, and we also develop completely new modeling systems that we use. This, as Kent mentioned, is what we're testing. Right now, the model prediction across scale, that's what you see in the upper right. The RRFS in the upper left, that's FP3 based. You might recognize that as the same model that the global forecasting system now uses, but this is at a regional instead of a global scale. And the bottom left is the old handy HER. It's been around for a long time that we all know and love. And as you see the animation go through, you see the different observed severe weather reports go along with the reflectivity, so you can kind of see how different models verify or don't verify. That's just a look at the RFS there on the top left. I've been key in getting that running both for our sake and at the CONUS level that is run, soon to be run, apparently, supposed to be run every day, as essentially a replacement for the HER. And then the MPAS there on the upper right, that's what we're looking into for perhaps future use in the war non-forecast system instead of the WRF. So that's one of the big questions that I'm working on answering is which model core will we use in the future. We're supposed to be replacing it with the FP3 core, but we might not. So soon to be answered, maybe, or maybe not. Thanks.
Well, hello, everybody. I'm Kim Hogewind. I'm a research scientist here with CIRO and NSSL. So I grew up across the pond from you guys, just outside of Grand Rapids, Michigan. And like Kent and Larissa, I was obsessed with thunderstorms from a very young age and knew I wanted to be a meteorologist when I grew up. However, once I graduated high school, I actually started as a Western Michigan Bronco, planning to study engineering, following the path of my dad, who was an engineer. Decided that was really boring. I was going to go to the rival Mac school, Central Michigan, and actually follow my dreams, where I got my bachelor's in meteorology and geography in 2009. After that, I went to Purdue University for graduate school, so another Purdue alum in the room here. While doing my master's, I actually was a SCEP intern, which that no longer exists. It's now the equivalent is, I believe, a pathways intern, where I worked with the forecast office in Grand Rapids, Michigan. But as I was, graduating with my master's, I really decided I didn't want to be a forecaster because the weather was boring most of the time, unless we got lots of snow or storms. So I decided to kind of continue on the research path. So I received my PhD from Purdue in 2016, where my dissertation research focused on using convection allowing models to study future climate projections of severe thunderstorms. From there, I just did another tour of the Midwest. I did 3 different postdoc positions, starting at the University of Illinois, just downstate from you all there. Then went back to Purdue, where I worked for a while at the Purdue Climate Change Research Center, and then back in my home department, working on something a little outside of my realm and tropical cyclones. Never taken a tropical class in my life, but that was a good learning experience. So after that, I actually applied for a position down here in Norman and received it. So I started out as a WARN on forecast liaison. So I was affiliated with SIMS, the Storm Prediction Center, NSSL, and I didn't list it here, but also the Environmental Modeling Center out in the DC area. I spent about a year in that position before I transitioned to my current role with CIRO NSSL to focus on something a little more closer to my background of severe weather and climate. So what do I do? As you might have gleaned from my first part of the presentation, is that I'm kind of a jack of all trades, but I would argue a master of none. So in my current position, and what I've done while I've been here is kind of focus on 4 main topics of looking at climatology and studying climate variability and climate change, and really studying that for the purpose of trying to see how we can push the boundaries in terms of predictability beyond, our current 1-week forecasts. So focus on predictability across time and space scales, kind of in alignment with the facets paradigm, or the forecasting a continuum of environmental threats. Did I get that right? I also do a lot of post-processing, visualization, and evaluation of forecasts. If you've seen the sounding viewer from the WARN on Forecast system, I initially developed that. I do a lot of web development now, and we do a lot of evaluation of extended range forecast systems from like global models, like the Global Ensemble Forecast System, or some newer cutting edge stuff coming out from GFDL, looking at extended range prediction using convection allowing models. Also been involved with the hazardous weather testbed spring forecasting experiment each year that I've been here. And hopefully next year, fingers crossed, we'll have kick off a new experiment, hopefully inaugural and happen annually of experiments looking specifically extended range prediction of severe convective storm hazards. Cool. And that's me in a nutshell.
Nice. I'll stop sharing the screen. I think that's everybody. So we can kind of get your reaction and just start a conversation. See what's on your mind.
Well, thanks for introducing yourself. I think we're super interested in all of your background. Thank you for that. I'm going to ask the first question, maybe to sort of spark some questions across the room. And I think it's the question on everyone's mind. Will we have the WAFs for Illinois tomorrow?
Yes, we will. At least that's the intent. I'm going to see. I think, yeah, I have. I do.
You prepared that question.
I was. I'm going to show you.
Screen.
Yeah. Actually, tomorrow is a first of its kind for us. So I've got this little screenshot here that I shared with the National Weather Service earlier. We are intending to run 2 domains.
You can't see your screen. It just says that you've started sharing. Can't quite see.
Oh.
Maybe share your full screen. I'm not sure if that's what you're doing.
You can go back and share the window.
Yeah. Okay.
That's the way Google Meets is better.
You'd have to
Yeah.
you'd have to open it to have a window to share.
What? Did I close it?
Okay, so yeah, maybe
Yeah.
could
Well, you know what?
window.
It's fine.
Oh, there you go.
Are you seeing me click around now?
Yeah, we can see the
Yeah.
screen up there.
All right. This is like insider baseball here, but I have an operations cheat sheet that reminds me how to do operations. And I just wanted to show you that this is like a preliminary look on those 2 red boxes. Where now that we have a cloud-based system, Warren Forecast was not cloud-based until last year. That opens up some possibilities for how to ramp up the compute power that we need to do more things. And so tomorrow we intend to have 2 domains running simultaneously, and certainly one of them will be that northern moderate risk area, and we'll have you covered.
So actually, just to go off of that, could you expand more on the decision-making process for when to implement it? You know, obviously, I think tomorrow categorically would be one of those slam dunk days, but, you know, enhanced, for example, in certain regions, is there things that you guys look for, variables you look for? What's sort of the factors that play in the discussion?
Yeah, good question. It's a matter of our research goals in a given year. We are always running during the spring forecasting experiment here at the hazardous weather test bed. So that's a good 4 or 5 week period in which there are daily runs on the weekdays. At other times of year, we've had special work that we've done with the Weather Prediction Center to look at flash flood cases. So we ran for a number of summer cases back in 2018 through 2020. Aside from those sort of funded efforts, it has been more a matter of trying to catch high impact events when they happen. So it's a little bit of an ad hoc thing. However, as we go forward, we're now talking with the Weather Service about transitioning the system to operations. And a component of that will be to ramp up the availability of runs so that more forecasters across the country can become comfortable with how to use the system. So that ramp up, we hope, will start next year with a pilot project, kind of where we'll let the Storm Prediction Center decide the domain for a number of runs. And the intent there is, like you said, to capture just about every enhanced risk plus that we can do. So I think in the coming years, we'll be attempting to do more and more.
And thank you for that response. I guess a follow-up question somewhat separate to that. I know there's been a couple of publications that highlight case studies to where WAFS was successful. Can you guys think of a time, I don't know if this has been published or not, but a time where there was fail mode with WAFS? And have you guys talked about a particular case more expansively on why it didn't work or things to improve on? Is there any notable event that you could think of where it did not come out as expected?
I have answers, but I don't want to dominate the conversations.
Well, I don't know what case you're gonna show, Patrick. I can think of a couple cases from last year during the HWT / Perils, Taurus. I'm trying to remember which field project was going on at the time. I think Taurus, that, you know, sometimes the data assimilation, and in those cases, it was kind of an instance of the low stratus, because we assimilate cloud water path observations as part of WAFS. And I think what was happening, like on that day, for example, is we were assimilating since the low stratus never really cleared, we were assimilating a lot of those observations, which was kind of artificially moistening the model environment. And so we were just getting a lot of, you know, convection developing where there wasn't convection that actually happened. And so that's one place where, you know, you can have you know, that's just on the top of my mind because we talked about it a lot. And we're thinking of ways to actually try to mitigate that. And we may implement it this year, or we're going to certainly look at implementing maybe some methods to kind of lessen that impact. You know, so that's one example of a case that I can think of where we didn't do as well.
Yeah. Yeah, and I don't know, are you seeing the screen still?
Are you sharing the screen?
I think you might need to share it again, Patrick.
Okay.
There we go.
Okay, should be seeing a slide. Yeah, this is something I put together recently. So one of the more common errors we have is when the environment impacts how we're handling the individual storms that are assimilated by radar. So in case number 1 here, there's a small error in dry line position in WAFS. And that means that we're putting the storms from radar geographically in the right place, but WAFS thinks they're in the dry air, so it squashes them. Whereas in reality, they went on to produce tornadoes in Kansas. Another problem is small or narrow convection, like this recent example in the upper right, where that line was simply too small to resolve, although it was severe and was severe warned. But to kind of get to the original question here, I think a good case to point to is the December quad state tornado outbreak. The image in the lower right, that's an ensemble probability of mid-level updraft rotation. And essentially it's a near zero probability from the WAFS ensembles. So none of the members were able to sustain that storm for whatever reason. It might have been a combination of both the environment being pretty sensitive and also the storm being a little bit small, not a real big, you know, long track kind of a April, May supercell. So we did find that if we rerun that case at higher resolution, like 1 kilometer grid spacing, that we do much better. So we don't have a lot of these high shear, low cape events in our catalog thus far. So it's kind of an open area of research. Certainly tomorrow may contribute to that.
So one of our professors, Dr. Ashley, is on the call and he raised his hand. So
yeah, I appreciate it, Kelvin, and I appreciate you all taking your time out of your busy days to meet with the students. I have a bigger question, I guess, with all the brain power that I'm staring at. You know, beyond just the fundamental meteorology, as an undergraduate student, what skill sets would you recommend an undergrad or a grad student really work on strengthening if they want to end up in that room with you all?
Big one is data processing. So coding, Python is growing. It's becoming really big. It's the #1 language for machine learning, and machine learning is growing incredibly large in popularity. So the ability to process large amounts of data. That's where we're at right now. You know, these weather data sets are 4-dimensional. They can be CONUS wide, they can be quite huge. So being able to understand data, being able to process data efficiently is a huge skill set.
Anyone else?
I'm on Fortran, but I'm like probably the only one in here who uses Fortran on a regular basis.
I mean, the
I
model
use
codes,
Fortran and
I
Rapid
mean-
to bring it into Python.
Yeah,
I mean, the
makes
model,
sense.
the model codes themselves are still written in, you know,
Yeah.
well, I mean, they're still Fortran based because you need the ability to crunch, you know, numbers very quickly. So whereas a lot of the post-processing has evolved to Python, I mean, I'm an old man, so I'm, you know, I'm of the NCL generation where that's what I learned, that Python wasn't as prevalent in kind of the mid to late 2000s into the early 2010s. So, and dealing with WRF, you know, there was a even older program that we used first, which was even more clunky, but it got us output. And a lot of that code had been kind of incorporated into NCL. So then NCL was just very nice for dealing with WRF. So any of my generation that dealt with WRF, a lot of us, you know, used NCL as kind of our primary coding language. But yeah, I mean, I know a lot of, I don't think any schools probably offer Fortran classes or even probably talk about it because hardly anyone uses it anymore. I know Purdue stopped doing Fortran when I left. So, you know, that was, you know, in the dark ages. So, so
I would say if you know any coding language,
yes,
you can learn to code in almost any other coding, because
yes,
you look at Python and Fortran and
Yeah.
the syntax is different, but it's not different. Like
The logic.
The logic is the
once
same.
yes, that's very true, Larissa. So once you understand the logic of coding, then it's just
It's all the same.
it's just syntax, learning new, you know,
Yeah.
you're learning the syntax differences.
And if you're like me and you
wanna do that.
never did get it with those technical kinds of things, I think being a good communicator
Mhm.
can get you a lot of the way. I don't have the technical skills that anybody else in the room here has. I mean, I envy you all. But I've just sort of made a career of,
You have the power of summation
yeah.
in a really good way, like in the best way possible.
Well, thank you.
Yeah.
Yeah. I coordinate people and times and places, and I take ideas and try to make them happen.
I mean, I'll say communication is important too. I mean, you know, not everybody necessarily does that, but being able to just, you know, explain in simple terms, which I struggle with, explaining in simple terms, like what you're doing, you know, being, you know, comfortable with presenting and just, you know, communication in general. I mean, social, you know, we have a, you know, social science group that, you know, is dealing with people, dealing with our stakeholders, collaborators and that, and that's a very new area of research that we're doing. And, you know, a big part, you know, we always talk about just running WAFs, but, you know, it was kind of a step is like, we got the system running, or like, we, you know, part of it is just personnel too, but just, hey, we can't display it. How do we do that? You know, how are we gonna make that work? So then we got people, and then we had skill sets to make that work. And then it was like, okay, now we have the output and it looks really nice. All right, how do we instruct, you know, the forecaster to use it? You know, our expertise of the science part then still has to be disseminated to them in a way that they can understand and take into account of their, you know, of their understanding of how to use WAFs and how to best use WAFs. So I think that's also an important area that is important for students.
I think I'll add on another thing for communication is being comfortable going and talking to people. Go talk to your professor, go talk to people at conferences. You don't realize how much building those connections matter. Like any one of these people in this room probably knew somebody that worked at CRO or knew somebody that worked at CRO and something. And so there's communication that happens that says, hey, Patrick, there's this position opening up. You should look into it. So don't be afraid to go out and talk to people.
I actually, when I was in a sort of desperate situation after I finished my master's degree, I didn't have any plans for I knew I wanted to get a PhD, but I didn't have an advisor set up. And I actually got an email from Patrick Marsh, who had been my classroom assistant in one class. And he told me about this PhD with Dave Stendrew. And I didn't know who Dave was. I didn't know how lucky I was to get to work with Dave censored, and I walked in, I interviewed, and he gave me the position on the spot. So a happen chance email from somebody that I was friendly with, that I was nice to. I was nice to my classroom assistant. So they thought of me, and then I ended up with Dave, and I wouldn't be here if I hadn't gotten that position. So sometimes just being nice and talking to people gets you emails that change your life.
It's a good point, that network.
Yeah, and you don't know you're building it when you're building it. It just happens.
Yeah, be honest, right? Like, don't try and go in like, oh, I want to meet you so that you're my connection.
I had no idea.
Try and be genuine with that person, right? Like, try to make it a genuine human connection, not just a,
People
I'm gonna
can
use
spell
you.
fake.
Yeah, I just want to use you to get that.
I'm gonna be straight with you. I just want to use you for professional gain.
Thank you all. That was a very good, hopefully provided a little bit more than, I feel like sometimes, was it Charlie Brown or Snoopy's teacher, whoever, wah, 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 wah. So I'm hopeful that the students hear these skill sets that oftentimes we sometimes have to develop outside of the classroom. And sometimes that can be really hard with our schedules, but I appreciate your time and effort today. Thank you.
Yeah, thanks for the question.
And I'll add to that time management, which I can only assume is becoming a more difficult skill to perfect nowadays with the increasing distractions. But I think time management is a big one, because I think it's very possible to, in the same amount of time, get twice as much done just by working more efficiently and not, allowing yourself to be distracted every 15 minutes. And I say that I remember as a grad student, observing some of the grad students around me, I could tell I was just getting a lot more done than them because I was focused. Not that I was hyper focused all the time and antisocial, but like I was able to get in the zone and not check social media every 20 minutes or, not find excuses to like.
How big was social media when you were in undergrad?
No, I'm still there. Well, yeah, I'm talking about grad school. Yeah,
That means it's even harder now, right?
Yeah,
it's even harder to.
Oh, it's way harder now than it was then.
Yeah, so I think that's really important. I think that's just a very good life skill to have in general.
Yeah, I'll just kind of follow that just as I thought. And I know a lot of people have, Twitter and have said this, but, just be careful what you post on, social media. It's not impossible that, somebody can find that and
Don't brag about things you shouldn't be bragging
use
about.
that against you, in case of certain situations. So, I know that's very, we don't need to get into weather Twitter arguments here. But just be careful because, and I'm sure all the students know about weather Twitter. So
The LRC predictions,
So-
definitely retweet.
So, just be careful. Don't, because people,
People read tweets.
People read tweets.
They remember
and
names.
they can names and can find out. So.
One thing I might add in addition, if I have a second, is just that you need to start becoming more comfortable teaching yourself new things. When it, like the programming part is you not always have a course to teach you, is you can go out and learn it on your own. I've never taken a Python course in my life. I taught myself from the ground up. So
I took one programming course and it was in C.
yeah, so I mean, sometimes it's a jarring change from going from undergraduate education, taking courses and learning new things there, and then you go out either grad school or the real world, and it can be a little uncomfortable at first trying to teach yourself, but it's actually a really good thing to be comfortable with being uncomfortable.
Yeah, I think that's one of the main goals of grad school is to teach you to teach yourself. And it is very gratifying to be able to do that.
Yeah, well, thank you for that. I know that's very useful advice for all of us. Are there any questions from the crowd? Yeah, Katie. Oh, we'll go Katie then Aaron. So we got a couple of questions coming down the pipeline.
Okay, so my question is, I'm a sophomore graduate. I literally don't know what I want to do, like, at all. So, like, you guys, I know some of you guys were talking about how you really didn't know what you wanted to do until this offer came up. But I'm just curious to know, like, were there any other paths that you didn't choose Yes, before this, and why did you choose what you recommend?
I think a lot of us probably kind of fell into it. I don't know about you guys. As far as like my specific specialty, I don't think I knew that I wanted to do model development, but when I got a chance to try it, I realized that I really loved coding and that I wanted to keep doing that. You've got a lot of time. I had no idea what I was doing as a sophomore. No idea.
Yeah, I mean, I'll say the
No
same thing too.
clue.
Like I was pretty sure I wanted to get a master's degree, but I didn't know what topic area.
Nope.
I didn't have really, even as a, maybe even a junior or senior, it was not until I went to, actually attended a workshop in Boulder, when I was a senior, that I started seeing, I didn't know what WRF was, and I knew what models were, didn't know what WRF was, but I saw for a field project that was going on at the time called BAMX, that they were doing WRF simulations of MCSs. And I saw how, even at that time, how like, oh, wow, that did a really good job. And I mean, this is very basic modeling, cold start models, deterministic. But that got me interested. It's like, oh, I didn't know a computer could do, the models at the time, what we had, you didn't see to that degree of resolution. So I was like, oh, wow, we actually are developing things like that. And so, that's got me started thinking about, numerical modeling, doing WRF simulations. And then it kind of naturally worked with me with Dr. Trapp, Purdue, doing QLCS mesovortex work. Just kind of naturally fell into like, oh, well, yeah, that's interesting. That's the type of, like mentioned earlier, that's the type of severe weather we had predominantly in Indiana. So that just kind of how it led me to that, doing that for my master's work. So
Sorry to interrupt whoever's next, but we can see you all right now. Just by a show of hands, who knew what they were going to do in undergrad or stayed on the track that they thought they were going to stay on throughout undergrad and into the years?
Well, it depends when in undergrad.
Maybe.
I knew I wanted a PhD, but I didn't know what I want, like, just because I knew I didn't want somebody telling me what to do all the time. Like, that was really what it was, is I wanted freedom to pursue avenues that I was interested in, but I had no idea what avenues those were going to be until I took an opportunity that just happened to interest me. I think that would probably be like, if you're feeling like you don't know what you want to do, just any opportunity that comes up that seems even like halfway interesting, like you wouldn't be bored out of your mind, just try it. Because you might find out that you love it, or you hate it and you don't do it again, and that's fine. But that's kind of what undergrad and like your first 2 years in grad school are for, is just figuring out what you like.
I mean, I'll say, most people, at least for my family, when I grew up, it's like, well, you want to do meteorology? Oh, you're going to be on TV.
Yeah. Oh gosh.
And, I knew I didn't want to be on TV. And I think, and then there's certainly more, I mean, even from when I was in college, there's so many more avenues that you can use meteorology and pair that with other skills and do something that's still meteorology related. But can still pique an interest maybe of something that's a little bit of a side thing. Like I'd like to talk about the social science aspect. That's still meteorology, where you still have to understand, it's very, I think that's having an understanding of meteorology and then bringing in the skills of the social science part, merging those two things together are very important, because you can see it from, both sides of the coin, not just being the science expert or just being the, more of the social science dealing with people kind of aspect. You can merge those things together. That's something that's even better. So,
Yeah. Maybe this is reassuring. I'm not sure, but sometimes I wonder what I want to be when I grow up still. And I love what I'm doing. I always thought I wanted to teach, be faculty, or, I'm not even sure what else. Would I want to be a forecaster? No, I kind of learned that a while ago. That wasn't the case. But one thing I kind of advocate is, if you think you might have an interest, try to find an internship or relationship to explore it, because in my opinion, is that it's just as useful to figure out what you don't want to do as it is to find what your passion is that you actually want to do.
Yeah, I agree with that. For some reason, and I can't for the life of me figure it out. Maybe it's too long ago. For a while, I thought I wanted to be a forecaster, and well into undergrad actually. So I didn't have things figured out from the get-go. And I think doing the weather challenge kind of helps teach me that, okay, maybe I'm not that interested in forecasting because it was such a pain. It's like, oh crap, I have to submit my forecast. I really don't feel like doing this. And then there's also, I think it was for the track I was on at Linden State, there's a required course that you had to issue forecasts and record forecasts for, I think it was a local radio station or something. And I hated that too. So yeah, I figured out at that point, okay, forecasting, probably is not for me. Although I don't know if I really made the decision until my now wife kind of, was questioning me like, wait a minute, why aren't you planning on going to grad school? And in retrospect, I'm like, I don't know what I was thinking, but for a while I was not planning on going to grad school. And I don't know why it wasn't obvious to me at that point that, going into forecasting was not the right path for me, given that I didn't like forecasting. And I certainly had the skill set to go to grad school and become a research scientist. So, but I did eventually figure it out. And an RU internship, the one I mentioned, the summer of my junior year definitely helped solidify it for me, where that was my first real research experience. Didn't have many opportunities to do research at a small school like Linden State. I think they're better about it now, but yeah, when I actually got to do some research as an undergrad, that I realized, oh yeah, I actually enjoy doing this. So yeah, actually having that experience helped a lot. So I think once I did that internship, I knew it was very clear to me I wanted to go to OU and at least get my master's.
I think we have another question over here. Aaron, do you still have it?
Yeah. Okay, so personally, I am a first generation university student, and I am not sure if I want to do graduate school. Is there still opportunities of your guys' levels for people who just have a bachelor's degree, or should I go to grad school?
The question is, can you still do research with a bachelor's degree? Is that the question?
Technically, in a way, like of your guys' jobs right now, I know you guys mostly have like masters and PhD. There's still like your level of job for people just a bachelor's degree.
I think for the most part,
At
at least the
math.
master's is required for research associates positions. So you'll be able to do research, but you won't be able to be independent and like choosing things. You're usually working under somebody else's guidance.
That's what the master's.
That's what the master's. Do we have?
We don't
Yes.
have any bachelor's.
Well, is the question for here, or is that a general question? Like, is the question about?
Question, just enough.
Yeah, I'm saying that the audio kind of comes in and out a little bit, maybe because you're a little far from the microphone, so we're not catching every word.
I think what Aaron is asking is just in a general sense, and sort of the positions that you're in. You kind of answered it, but bachelor's, does that work, or that still be
I mean, I think even forecasters nowadays, a lot of them have masters. Like, you're gonna get beaten out by people with masters,
Yeah.
unless you have connections and you've done a lot of
Yes.
internships.
Yeah, it's tough to be competitive. So it's not that you can't do it, but you'd have to be a very stellar.
Well, if you make the right connections and you do lots of internships and you have offices that want you, they'll find a way to bring you on.
Right.
So I think if you only have a bachelor's degree and you want to do a certain kind of job, having connections and people work with you, like if you've done an internship with them and they've seen your work ethic and they know that you're a good fit for their office, that can overwhelm other, maybe a degree that they were looking for, because they know you're good and they know you will fit.
Yeah.
So I'd say if if you have kinds of jobs in mind, but you don't want to do more schooling, really build your network of people that you know and try to do lots of internships. Because I've watched kids who who a master's degree was not for them. So they built good relationships and they got jobs that most people wouldn't have gotten right out of undergrad because they knew people. So, yeah. Because that master's degree isn't for everybody.
Yeah. And of course, there are plenty of bachelor's positions out there otherwise. you
Yeah.
know.
Yeah.
Otherwise, they don't
Lots of
want
stuff
people
in private
graduating
sector.
and-
Yeah, private
Yeah,
sector.
Lots of stuff in
Sector.
private sector.
Yeah.
I know people who ended up in GIS positions, people who work for like Amazon doing weather related stuff. I mean,
Mhm.
there's all kinds
All
of
kinds of
weather
stuff.
adjacent
Yeah.
stuff in the private sector.
Yeah.
Yeah, any other questions in the audience? Landon? Yeah, so regarding the future of numerical weather prediction, how important is it to you guys for the move from like more deterministic models to ensembles and probabilistic products?
Yeah, that's a nice question. If I understood, you're talking about the general shift away from determinism towards probabilistic systems. And yeah, I mean, I think our group is really helping to lead the way in that at the storm scale, at the 0 to 6 hour time frame. We're on forecast is really one of the first technologies that's come along to help the Weather Service transition to that kind of a mindset of framing individual thunderstorms at the city level in a probabilistic framework. So that's something that's been building and that we've committed to as a science and as an agency within NOAA, that we've said that's where we want to go, is towards probabilistic description of hazards from like Kim scale out at 8 days all the way down to the warning scale. And that's easier said than done, because everything for decades has been, particularly when it comes to severe storm warnings, has been a very deterministic yes or no, you're in a warning or you're not, kind of a mindset. So we're trying to change culture essentially, but you do that in part by developing new tools that allow you to see the problem differently, visualize it differently, and then by testing new ways of operating, and we do a lot of that in the test bed here. So I guess a simpler way to put all this is that if you look at the Warren forecast system, there is no control member. All the members are treated equally. And they're all the same resolution and everything. So the output from Warren forecast is intentionally designed to emphasize the probability and percentile products rather than the individual members.
We do look at individual numbers if we're curious about various things, but that's rarely what you expect the end user to be looking at.
Well, maybe what we don't
We
want
don't,
them
yeah,
going
yeah,
to
that's what I mean,
first,
that's the last like deep dive.
Yeah, we kind of coach people, I think, to start with the overview products, and if they identify a specific threat, then you can start digging through the members, saying, okay, was this like 2 members, was it 4 members?
Because sometimes seeing the members yourself can give you a better feel for what it actually looks like.
Yeah.
Thanks. We have a couple more minutes. I'm just gonna cap it off with one last question. Unless somebody else has a question that they really want to ask. Anyone? No. So I noticed that a bunch of you mentioned machine learning in your introductions. And I know there's a lot of research going on here at NIU in regards to machine learning. Jeremy, you're doing research on machine learning, yes. So a lot of research going on, and I know I've heard some of the professors say that it's sort of the future in terms of parts of prediction. How would you say we can build our understanding of machine learning or practice it, so to speak, while we're in college, whether it be undergrad or graduate school, to sort of be prepared for what might be the future?
That's you, Monty, or Corey.
Yeah. let's do this. Look at that.
There are a lot of tutorials out there. I do recommend you'd have to, so maybe I can have Burke send you the link, but there's an organization that we collaborate with here at OU called AI2ES. And it's probably one of the largest organizations working towards trying to build AI systems for environmental science. So ocean prediction, climate prediction, hail, thunderstorms, snow. And they've actually ran 2 summer schools over the past two years that show you how to train machine learning models, loading the data, seeing some of the Python code behind it. So I can have Burke send that on to you to try and get familiar with that. Otherwise, there's a lot of good tutorial material out there. I think there's even data sets that are atmospheric science related that can give you kind of a quick 101. So you might see stuff out there about deep learning and all the stuff behind like ChatGPT. That's probably a little bit too much to start out with. There's a lot of fun, more traditional stuff like logistic regression, random forests, that might be an easier way to kind of, start to cut your teeth, so to speak, on using AI and stuff like that. So I would recommend starting very, very simple. There's a lot of great, YouTube videos out there explaining some of these algorithms. There's a lot of great resources out there for being able to kind of like run the code yourself. So I would recommend start simple. Don't try and jump off the deep learning, 100 trillion parameter models. Probably a little bit.
Thought you were gonna say jump off the deep learning end.
I was hoping.
Didn't Brian Lagerquist and DJ Gagne, didn't they develop something recently? I thought that I could have sworn I remember seeing something where they developed some sort of like tutorial or something that was obviously explicitly atmospheric science related, because that's what they do.
Yeah, so there's actually, I can have him send that.
Because that was my first thought, because I knew that was out there.
No, this wasn't, this was developed a little while ago, but David Gagne, Gagne, he actually has a GitHub repository called SwirlNet that has data available to you and Python code available to you to try and basically the problem is, imagine you had model output, like forecast model output, and what the current state is, and you're trying to predict like the vertical velocity field, like 5 minutes from now. That's how that data set is set up. And then, so it's a very environmental science friendly data set, and it goes through like loading the data, training models, like understanding what's going on. So again, I can have Burke send that on to you, but it's David Gagne and it's SwirlNet.
Is there anything else on your guys' end?
No, I did want to thank you all for being patient with us in the reschedule. I know we were supposed to have done this back in February, but as it turns out, I mean, everybody's looking ahead to tomorrow.
I was gonna say it
anyway,
turned out well.
Yeah, it turned out really well. So, and I appreciate the back and forth and the questions. This has been great.
So some of the people in the room want to know where we might be able to contact you guys, or if your contact is sort of public information that we can get on your website, or if you could send that over to us, or if you just want to say it.
Yeah, maybe I'll share with you the slideshow and I'll just put a little contact slide in there with our email addresses.
Okay, awesome. Well, thank you guys. very informative meeting. For everyone else out there, again, on the 11th, we have Liz Lightman from the Storm Prediction Center. That's in April. A few more social events. Elections are coming up on April 19th for AMS, so we hope that we can have you out for elections as well. We have a pretty good field of candidates, so that's what we got. Thank you, guys. Thanks to everybody for coming.
All right, thanks.
Thank you.
Happy chasing tomorrow.
Yeah.
Be safe.
Stay safe.
Yeah, be safe.
That's for sure.